So the purpose of this program is to take three numbers inputted by the user and determine whether or not they can be the sides of a triangle. And if they can be, then it solves for the angles of the triangle and the area, and determines what classification the triangle is. So after clearing home, the calculator prompts three numbers to be used as the sides of the triangle. It then determines whether or not the three values can be used as the sides of the triangle. So in order for the triangle to exist, any two of the sides must be added up and equal to a length greater than that of the remaining side. If this is not true, then a triangle cannot exist. So after determining that a plus b is greater than c, a plus c is greater than b, and b plus c is greater than a, then we know that the triangle exists. So after we know that the triangle exists, the law of cosines can be used to solve for the angles, since all three sides are already known. So each of the angles are solved for individually by the law of cosines, and assign the variables d, e, and f in this program. So after solving for the angles of the triangle is completely solved since we know all three sides and all three angles. So what's left is to determine the classification of the triangle and its area. So to determine the classification, we must determine whether or not it's equilateral, scalene, or isosceles. So to be equilateral, all three sides must be equal. So if a equals b equals c, then all three sides would be equal, so the program would display equilateral. Now, if none of the sides were equal, then it would be scalene. So if a does not equal b, a does not equal c, and b does not equal c, then the triangle would be scalene, and that is what would be displayed by the code. Now, if none of those two conditions were met, then isosceles is the third remaining choice and the only possible option if the triangle is not equilateral or scalene. So there's no need to include a conditional for isosceles. We can just leave it as a third option. Now we can determine the angle classification by first determining whether or not it's an obtuse triangle. So if any of the angles are greater than 90, D, E, or F, then it would be an obtuse triangle by definition. Now, if none of the angles are greater than 90, then it will not be an obtuse, and it could either be a right triangle or an acute triangle. To determine whether or not it's a right triangle, we'll evaluate whether or not any of the angles are equal to 90. If any of the angles are equal to 90, then it is a right triangle. And if they're not, then the only remaining option is acute, so we don't need to include a conditional for that. So after determining both classifications of the triangle and all three angles, and we already had all three sides to start with, the only thing that remains is the area. So here the calculator displays the three sides that were entered, the three angles for which it solved, and in order to find the area, we use the formula 0.5 BC sine D, which represents angle A, and that is equal to the area of the triangle. After solving for the area is displayed, and that completes all the information about the triangle, which is now completely solved. Now there's one option which we didn't discuss, which that if the conditional in the very beginning was not met, where any two sides could add up and would have to equal a length greater than that of the remaining side, then the triangle would not exist. So, to close the very first if statement, if any two sides added up do not necessarily equal a length greater than that of the third side, then no such triangle exists, and that will be made clear by the program which displays the message, no such triangle exists. Thank you for watching.